right, here we are, chapter 3.1 of our college algebra textbook by Martin Gay. And we're talking complex numbers here, a topic that we did in intermediate algebra. So hopefully this is a refresher. And our goal here is to get these complex numbers in the form of I square root of A. So as a reminder again, when we have a negative square root now, we can take it out and it involves the imaginary number. So basically this is negative 1 times the square root of 16. So we know that the square root of negative 1, square root of negative 1 equals I. And we also know that negative 1 equals I squared. Alright, so now I've got this square root, so I could break this down to be the square root of negative 1 times the square root of 16. Square root of negative 1 is the I times square root of 16 is 4. So this invariably we end up with 4I as our solution. Okay, that's all there is to it. Take out the negative with an I, and then you will have, so this one I'll do a little differently. This is the I that comes out, then I'm left with the square root of 75. Square root of 75 would break down to be 25 times 3. I could do it this way, square root of 25 times 3, and the square root of 25 is 5. So the 5 comes out and joins the I, and then I have left is the square root of 3, which is just the square root of 3. We can't simplify the square root of 3. Alright, let's go to adding and subtracting complex numbers. Alright, so here this is similar to adding and subtracting polynomials, if you will, and in particular binomials. So the key thing to watch for is the sign in between that says to add them. Students, many times students make the mistake and they see these two binomials, so they'll start doing the FOIL thing and start multiplying them. No, this in particular is saying to add them. So if we add them, there's nothing to do but drop the parentheses and combine your like terms. So in this case I got 3 and minus 2 is 1. And then negative 4 plus 6i is going to be plus 2i. And remember, we write this in the form of a plus bi, always, for our complex numbers. And that's in the right form of 1 plus 2i is a plus 2i. Easy. Very easy. Next one, same thing. It's a plus sign, I'm adding them, so I just combine my like terms. Negative 9 and 3 is negative 6, and 7i minus 15i is negative 18i. Now this is a subtraction one, right? So when I subtract this binomial, I have to distribute the negative 1 across it. Okay, so that would look like, I'll rewrite it. Negative 4 plus 3i minus 6 plus 7i. And now I'll combine my like terms. Negative 4 minus 6 is negative 10. And 3i plus 7i is plus 10i. That's it. Remember to distribute that negative because that middle term is a subtraction sign. And we want to make sure we do that correctly. And the last one here, minus sign. So again, I'm going to, this is just me doing it this way. I got 12. I want to make sure I don't make a mistake. So I go 12 minus 5i. I'll distribute the negative as I go. It's negative 8. Negative 1 times negative 3i is positive 3i. That works for me. Sometimes people will put this underneath the first part. So if I had negative 1 times 8 is negative 8, put it here. And negative 1 times negative 3i is the positive 3i, and put that here, right underneath it, the like column. and then you can just bring it down. Then you'd have 4 minus, what is that, 2i. And there would be your solution for that one. Either way. All right, when we multiply these complex number, now these are clearly two binomials that are multiplied together, so we will use the method, or just multiplying. And what is that? First, 5 times 7, 35. Outside is going to be negative 10i. Oh, let's see here, I got something wrong. 10i. Try this. Okay, and then 10i, and what else? First, outside, inside is negative 28i. And last now is the part you have to be careful of. This is negative 4 times negative 2. It's positive 8i squared. But remember, the I squared equals negative 1. So what we're going to do is just take that negative 1 times 8 and change this to be negative 8. Then you'll do your combining. So now you got 35 minus 8, which is 27, minus 38i. Okay, that's it. I squared at the end. Make sure you adjust for the negative, and you'll be on your way. Here we go, another one. We can just FOIL this, but I also notice that these are the product of the same two terms. Okay, I could do the shortcut way of doing this, but let's just FOIL it. 6 times 6 is 36. Outside is negative 30i. Inside is positive 30i. And last is going to be negative 25i squared. Alright, so we know the middle terms here are going to cancel. One's negative, one's positive. Negative 30 and positive 30. And then I've got this negative 25i squared. And remember, this is negative 25 times negative 1 now, which makes it 25. Then you have 36 plus 25. 61. Bingo. Got it. Okay, in our last section here of 3.1, second to the last topic here, we've got simplifying powers of I. It's one of my favorite topics here. It's fun because what you have to remember and realize that is when we break these down, I could break this down, I'm going to go up to I to the third power. So if I have I to the 0 power equals 1, I to the first power equals I to the second power is negative 1, and then I to the third power equals negative I. Okay, and just so you break that down, it's I squared times I is I to the third, and then this I squared is negative 1 times I, which is negative I. That's how we come up with that. All right, so now we know that there are these 4 terms that you want to jot down somewhere before the exam, or memorize it anyway. And our exponents here are going to apply to the remainder of the way I'm going to show you how to do this. All right, so here's how it goes. If I've got a problem, the first one is I to the 13th. I could do this, any number here is going to work for me. So I to the 13th. So over here I'm going to go a little sidebar and say I'm going to divide 4 into 13. The 4 comes from these 4 terms. 1, 2, 3, 4. When I divide 4 into 13, do the math however you can, but you're interested in what's the remainder, or what the remainder is. 4 into 13 is 3 times. 3 times 4 is 12. subtract, I have a remainder of 1. Therefore, my simplified power of I for I to the 13th is I to the first. And I to the first equals I. Okay, so I'm doing division here to get my remainder of the numerical number that will correspond with the exponent. That's what's happening here. What's another one here? I got I to the 56. Sidebar, I'm going to divide 4 into 56. 4 into 56 goes 14 times. 14 times 4, 56. 0 remainder. If I have a 0 remainder, I'll come up here and it's I to the 0 equals 1. So I to the 56 equals 1. Okay, I'm going to do one that's not in the textbook. How about just I to the, I to the 99. I to the 99th power. Okay. So how about a little side work here? I'm going to say 99 divided by 4. I want the remainder now. 4 goes into 9 2 times. 2 times 4 is 8. Subtract. I get 1 9. 4 goes into 19. Not 5 times, but 4 times. 4 times 4 is 16. Subtract, I have a remainder of 3. Fran? Okay, I forgot where I was before I was interrupted, and I was doing the I to the 99th power. I did the division. I had a remainder of 3, so the answer to I to the 99th power will be I to the, with a 3 remainder, I've got I to the 3rd power, so this is going to give me negative I, corresponding the remainder with the exponent of the I. Okay, and that was that one. There was one more with a negative exponent. Let's go through that one. And it is I to the negative 3. All right, same idea here. This is only up to 3, so we already know what 3 is. So we would rewrite this. I have to change this to a positive exponent, so it would be 1 over I cubed as such. So now it's positive. The 3 is the remainder, and I can just go back up to the chart and say this is I to the 3, which is negative I. So this would equal 1 over negative I, which is the same as negative 1 over I. Okay, and that's how you handle the simplification of the powers of I. All right, when we're dividing complex number, as a reminder again that we multiply by the conjugate of the denominator. And the conjugate is going to be, in this case, I've got 3 plus I, so I'm going to multiply top and bottom by 3 minus I. Top and bottom. So now I've got this idea of the product of the same two terms. Remember that, and or FOIL it, but I'm going to start with the complex conjugate by doing the shortcut way. And what was that? So I've got 3 plus I could use that, and what do I know about it? So I'm going to take the first term, the 3, and square it. That gives you 9. It's always minus when you do the FOIL, meaning I, positive I times negative I is negative I squared. See, that's always the case when you're multiplying the sum and the difference. So regardless of that, I'm going to take the first term, square it. It's always minus in between. I'm going to take the second term and square it, which is I squared. And I squared is negative 1. So it's going to be 9 minus negative 1, which equals 9 plus 1, which equals 10. Okay, so my denominator here is going to be 10. And then I got to determine what I got to multiply this out by foiling the numerators. Okay, when I foil that, just regular foiling. And what is that? So it's this times this. So I got 7 times 3 is 21. Outside is negative 7i. Inside is negative 3i. And last is positive I squared. However, I squared is negative 1. So this is going to be minus 1. Okay, so kind of do that if I want. And now I'll combine my like terms. So what I got? 21 minus 1 is 20. And then I got negative 7i minus 3i is negative 10i. And that's it here. That's my numerator. It's going to go up here. 20 minus 10i. Okay, then, you could rewrite this to be, let's see, I'll scooch over here a little bit. I can rewrite this to be 20 over 10 minus 10i over 10. An equal expression that way. So 20 divided by 10 is 2, and that's going to be minus, well, 10s cancel out, you're left with the I. So here's my solution for that. So you can look at it splitting it up to do your simplifying, or you could factor out a 10 and the 10 would cancel or whatever. So either way is fine. Okay, here's another one. Same concept. I want to multiply top and bottom by the conjugate of 5 minus I, which is 5 plus I. Top and bottom. Okay, here, FOIL the bottom, or sum and difference of the same two terms, which is a big reason why we do this. So I'm going to have my denominator here is going to be 25, 5 times 5, minus I squared. Square the first term, 25, square the second term, I squared, and it's always minus. So again, this is going to be 25 plus 1, which is 26. Then when I FOIL the numerator here, what have I got? Well, let's bring it over here. I've got 15. Outside is positive 3i. Inside is 10i. Last is going to be positive 2i squared. But I squared was negative 1, so this last part is going to change to minus 2. Negative 1 times 2 is negative 2. Excuse me. Combining my like terms, I got 13 plus 13i. If I put it each of these over 26, which is this numerator here, 13 over 26 is 1/2, and it's going to be plus, what happens here? I over 2, plus I over 2. So there you go. That's an I there, so make sure that's clear, because we'll be mistaken for a 1. All right, but there's my answer in the needed form. If I wrote it here, I could say if this is 13 plus 13i, if I factored out a 13, and then I would write 1 plus I, and then what have I got? I've got 13 goes into 13 once, 13 into 26 twice. So this could be written as 1 plus I over 13. Oh, no, I'm sorry, not 13, 2. Over 2. So this and this are equal expressions then. One more. No, I won't even change the page here. I'll do it this way. 3 over I. All right, so the conjugate is going to be times top and bottom by negative I. Negative I. All right, so let's see, what have I got here? I've got negative 3I over negative I squared. And again, negative I, or I squared is negative 1. So this is going to be negative 3I over negative 1, which is negative 3I over positive 1, which equals negative 3I. Okay, so here's my quotient from that division problem. If I wanted to check it, I take the 3 over the I, just so you kind of know that the properties are holding steadfast. They're still true from our elementary learning to now using imaginary numbers. So if I got 3 divided by I equals negative 3I, and then how do I check that? Well, I'm going to multiply the quotient, which is the negative 3I, by the divisor of I times I, and the answer should be 3. So I got negative 3I times I is negative 3I squared. And the I squared is negative 1, so it's 3 times negative 1, negative 3 times negative 1, which equals positive 3. So this 3 and this 3 match, and proving that this works. All right, that's it for 3.1.